Hello friends, this is Dr. Harsharif Joshi from Mechanical Engineering Department, Dr. Babasaheb Ambedkar Technological University, Lonere, Maharashtra. We are discussing about the subject robotics, which is elective for final year students. Now we'll go to the unit number 5, which is robot programming. For convenience, this unit has been divided into parts. So today we'll discuss about the first part, that is a lead through programming methods. So let us see the contents, what we are going to discuss today. Firstly, we'll discuss about functions of robot programming, methods of robot programming. In this particular discussion, we'll mainly focus on lead through programming methods. Then we'll finally end up with path planning for robot programs. And in the next part, we'll be talking about the other method, that is textual. So let us begin our discussion with functions of robot programming. So this means what is the requirement for programming of a robot? We already discussed, we started our discussion with the construction of the robot, we started our discussion with the configuration of the robot, then we started with the giving power to the robot through the drives, then we discussed about giving intelligence to the robot through the sensors, then we discussed about the control part of the robot, and now we are in the discussion for programming. So what is the requirement of the programming? So there are different requirements from the robots to be completed. So for that, we need to program the robots. So the first one amongst that is the motion programming. We expect the end effector of the robot to move from one point to other point, and that is what we call it as a motion programming. Now, as if you remember in our discussion, we had discussed about different types of robot. In that, one was the stationary and the other one was the mobile robot. So in case of a stationary robot, it will be motion programming will mainly be about the positions of the end effector of the robot or the tool for the robot. And in case of a mobile robot, it can even include the mobility of the robot from one place to other place. So when the robot is supposed to do the functions at different locations, so its location and the location of its end effector both put together. In case of stationary robot, as the name indicates, the base is going to be always constant. So we'll always talk about movement of the end effector with respect to the base. Whereas in case of mobile robot, once again we are always talking about the position of the end effector of the robot, but now the position of end effector will be with respect to some absolute base, or maybe with respect to the main absolute frame of reference. So this is how actually for example, one point is given here that a command like move to A1, for example, if I want to move the end effector of the robot to a point named as A1, then I'll have to use the motion programming for doing that particular type of task. Next requirement from the robot programming can be, we also want to operate the grippers. For example, if I have now moved to the point A1 and I want to pick up an object which is placed at point A1, I need to use my gripper or end effector, like for example, it may be a drilling machine or drill. It can be sometimes the, let us say, a spray painting gun. So I may need to give the command to that spray painting gun that now you have reached to the location where you are supposed to do the function, and then you have to start the operation after reaching to that particular point. In the similar fashion, it can be a gripper. For example, if the end effector has now reached to a position, let us say A1, and now I'll ask the gripper to pick up that object. So the gripper has to be again closed, and then the next motion command can be given that, let us say, move to a point B1 or maybe A2 or something. So this is what the gripper or end effector control is concerned, and that is also a function of a robot programming concept. Next one is operating parameters setting. For example, whenever we want to operate, let us say if you have a drill and now we want to operate that drill, then we need to specify the speed, we need to specify the torque, we need to specify at what location it has to work. So all those parameters, operating parameters for that matter, are to be set in case of robots. So this particular function can be done with the help of operating parameter setting. If you remember, when we are talking about various parameters related to the robot, we have talked about the joint speed in all the cases. So as we have discussed at that particular point of time, the speeds are normally designated in terms of percentage of speed. So we need to specify, let us say, a particular joint, if I want to operate it at 100% of the speed, or I want to operate that particular joint at 50% of the speed, or whatever other values are there, so that we can specify into this operating parameter settings using the robot programming. Next one is sensor control. As we have discussed earlier, once again, the sensors are basically the intelligence of the robot. So we need to use some commands for activating the sensors. Some of the sensors may be always active. Some of the sensors may be activated whenever they are required. Some of the sensors will be used as interlocks. So what has to be done with these sensors and how these sensors are supposed to be operated, all those things will be based upon the sensor commands, which are also a function of robot programming. Next function is communicating with the other robot or other systems, especially when we are talking about industrial robots. So the coordination between the various robots within the organization or within the industry, or sometimes the coordination of the robot with the machine. For example, if you are going to use the robot for loading and unloading of a CNC machine, so there has to be a communication between the machine and the robot, so as to make the system more and more automatic. So it may happen that we may require that if the job has been completed on a CNC machine, then that will be communicated to the robot. The robot will pick up the job and it will place it to and it will place it to the finished components, and probably it may load a fresh job onto the robot, onto the CNC machine. So like this, the communication between the machine and the robot, or sometimes it may be a communication between two or more robots. That communication may be to just avoid the obstacle. The communication may be just to ensure that at least some of the robot is attending a particular situation. So like that, there can be the needs for communication, and this type of commands are available into robot programming so that the robots can communicate with each other. Next one is safety subroutine. Sometimes there can be some requirements where the emergency stops may be required, some immediate action may be required to be taken by the robots. So in that case, there has to be a provision which we typically call it as a safety subroutines. We'll be discussing in more details when we'll be talking about the subroutines of the textual programming language later in this unit. But at this point of time, it is enough to understand that there is also a need to have some programs which are typically called as safety subroutines, and that is also a function of language. Now we'll move to the next part, that is methods of robot programming. As we discussed at the beginning, there are basically two main methods of robot programming. The first one is called as lead-through programming, and the other one is called as textual programming languages. As the name indicates, lead-through programming is not using the textual programming languages. There are mainly two types of lead-through programmings. One is manual lead-through programming. The other one is called as powered lead-through programming. Manual lead-through programming is also called as walk-through programming, and powered lead-through programming is typically called as teach pendant mode of programming. In today's discussion, we'll be mainly focusing on the lead-through programming methods, that is walk-through method, manual lead-through programming, or teach pendant method, which is also called as powered lead-through method. Textual programming languages will be discussing into the second part of this this presentation. Let's now start our discussion with the manual lead-through programming method, which is also called as walk-through programming method. This programming method is one of the popular programming method used for the robot programs. This is typically used whenever we need to program the robot for a continuous path programming involving complex curvilinear motions. As we have discussed in case of different types of controllers for the robots, we have discussed about the continuous path control of the robot. If your requirement is of that particular type, if you remember the different applications which we had discussed at that particular point of time, where basically the applications like spray painting, arc welding, gluing, this type of applications where we require a continuous path to be programmed. So in that case, this particular type of programming is very suitable. You can imagine a particular application where the arc welding has to be done, or let us say a spray painting has to be done onto a bonnet of a car, which is actually a complex shape. So if we need to program it through the textual programming languages, it will be a very big task for the programmer to identify the coordinates at every locations and then program the motions accordingly. Similarly, to maintain the gap for the arc welding will also be a very difficult task for the programmer. However, if we go through the manual lead-through programming, which we also call it as a walkthrough programming, it will become very easier to use it in case of the programming for the robot. We need to understand for that reason what we actually mean by manual lead-through programming. So in a manual lead-through programming, typically what we do is we will hold the arm of the robot or the end effector of the robot, and then the arm is moved through the series of paths or series of points or the path whatever is required. For example, if we are going to have a spray painting operation, then we may use a scaled operator to do that particular task. As you are aware, in case of spray painting, most important one is to save the paint. The paint should not be wasted. And the second requirement is there that the coat of the paint should be uniform. If you just pass on the same point again and again, then at some points the coat may become thicker, whereas at some other points the coat may be very thin, which is not good painting. So there may be a skilled operator, and we want to capture the skills of that skilled operator so as to do that task repeatedly again and again, any number of times through the robots. So the skilled operator will hold a spray gun which is at the end of the robot wrist or at the robot end effector, and then he will do this operation of spray painting, while the robot will be capturing the motions which are being followed by the operator, and those motions will be recorded, and for any number of times for the next cycles, the same cycle of motions or the operation will be continued by the robot. Obviously, the textual programming is not involved into this, or very little requirement will be there to give the textual commands. So this method of programming is very easy. However, the programming mainly depends upon the skills of the operator. That is one of the drawback of this particular type of system. One major drawback of this system is that sometimes the operator becomes cautious, or which may affect the performance of the operator. You can understand, whenever you are being monitored by somebody or if your activities are being recorded, then obviously we become cautious and probably we may not be able to perform naturally the way we will perform otherwise. Even if you can take the example of this particular presentation, whenever we are discussing in the class, obviously the way of presentation, way of delivery of lectures is very different, whereas because this is getting recorded, so obviously there is some difference in the way we are presenting the things, or we are delivering the things. So that is one of the major drawback of manual lead-through programming, especially in the industrial environment. Many times the operator may think in a sense that if I transfer my knowledge, if I transfer my skills to the machine, then I will be jobless. So probably that is also one kind of a psychological hurdle which is experienced while using a manual lead-through programming. However, as mentioned earlier, this is one of the easiest method of programming, and especially for the continuous path programming, this is the only option available for programming, or this will give always the better results. A link has been provided in the description box where you can see a video related to manual lead-through programming. Now we'll discuss about a power lead-through. As the name indicates, instead of a manual or an operator holding the hand and moving the end effector of the robot, we can give that particular motion through power, and this is typically called as a teach pendant mode. In this teach pendant, typically a small handheld remote is involved into this. Sometimes it may be wired or sometimes it can be even wireless, which is controlling the robot. So instead of holding the robot in hand, we are controlling it through the remote which is available in our hand and which is called as a teach pendant. This may also have some additional buttons in addition to control the motion of the robot. There can be few additional buttons. For example, if you want to just teach the robot the different location, different points, then there can be a button like here A1 or here A2, something like that, so that we can key in the different points and we can teach the robot that this is the point of our interest. So just read the coordinates of this particular point and store it into your memory, which can be afterwards used for the programming. So as the name indicates, instead of having a manual movement, we can operate the robot through a remote control. So obviously you can understand the level of difficulty which will be there in operating the robot, because you do not have the direct control on the motions of the robot. So this type of system is more suitable for the applications where point-to-point programming is involved. The applications like spot welding, riveting, or pick and place type of operations, assembly type of operations. We may use this because only the final and the initial points are of our concern in this case, whereas the path which the robot is following is not a major concern in this type of applications unless and until it is a straight line path expected. This is also suitable for the applications where the operator cannot reach. For example, in case of a nuclear power plant, suppose you want to program a robot for the nuclear power plant, then the manual lead through programming is not possible because it is not safe to send a human operator inside the nuclear reactor. So, and in such particular case, we may operate the robot remotely through the teach pendant, and then we can teach the robot the process or the operation which it has to perform, which the robot will keep on repeating again and again whenever it is required. This is again relatively easier method of programming. That if you observe here, a word relatively has been intentionally added because it is easier than textual programming methods. However, it is slightly complex compared to the manual lead through programming which we have just now discussed. Let me add one point here, that not only the textual programming, even though for the academic purpose we are dividing this into two parts, one is powered lead through and manual lead through, and the other one is the textual programming languages. For all practical purposes, we may use either of these methods, or we may even use combination of these methods. For example, for teaching the robot about a particular point, we may just use the teach pendant, whereas for the operation to be done at that particular point, we may use the textual programming language, or we may use the powered lead through at some particular part of the program, and we may use a manual lead through for some particular part of the program. As mentioned earlier, a link has been provided in the description to this video, where you can see a small video about operating a robot with the help of powered lead through. Now let us discuss about the path planning. As we have defined the robot as a programmable multi-purpose manipulator. So as the name manipulator indicates, it has to move through series of motions or series of operations. So most important for us is the path planning for the robot. We have to understand at this point of time that the robot is typically made up of multiple joints, and the same endpoint can be achieved by various combinations of the joint positions. You need to recall at this point of time the joint coordinate system and the word coordinate system. So a particular point with the word coordinate system can be addressed by more than one way of representation. by using a joint positions. All the combinations may not be suitable. Even though there are multiple combinations available, some of the constraints may be there. For example, if you want to approach to a point from the top side, and the other combinations may not be approaching from the top side, or sometimes it may happen that you want to approach to a point from the bottom side, but there is some obstacle in between. So even though there can be a simpler option of joint positions available to reach to that particular point, you may have to use some complex combination of joint positions to reach to a particular location, or difficult to reach locations in that case. For reaching to a location, more than one path can be followed. So now we'll discuss about what are the different methods of defining positions in space, because we are talking about an actual three-dimensional robot. So defining a point indirectly means defining a position in space. So in case of robot, there are three types of methods which are used for defining a position in space. The first one is called as joint movement, or we typically we call it as a joint coordinate system, which we have already discussed in our second unit while discussing the robot kinematics. That means for reaching to a particular point, we'll give the movement by each of the joint, and one of the advantage of this system is that if the joint movements are described, that will always indicate one and only one particular final position of the end effector, or we typically call it as a unique final position of the end effector. Next method is word coordinate system, typically the XYZ coordinate system of the end effector. This also we already discussed, word coordinate system, where XY coordinate of the end effector is defined. But as we have just now discussed, the main drawback of this particular system is that a particular XYZ position can be defined by multiple joint position systems for a particular robot. So if you are defining a XYZ coordinate system in a robot program, we need to also take care of what particular joint combination we are talking about, or what particular joint combination we need to use in that particular application. If there are any restrictions onto that particular motion, if there are some restrictions onto that particular combination, it may happen in some of the applications that it may not really matter anyway if it is reaching to a required position that is good enough, especially if you are handling a robot in an open space for a pick and place operation. There are no other restrictions onto the robot, then XYZ coordinates of that particular point may be enough. But in many of the applications there are some restrictions, so we need to define that separately during the programming. However, the advantage of this system is that it is very easy and self-intuitive, because we always know the position of a particular point in the space in terms of XYZ, whereas we are discussing in case of robot kinematics that converting that from XYZ to a joint coordinate system is a big task, which we had already done in our second unit. Third coordinate system is typically called as a tool coordinate system. In case of joint coordinate system or a word coordinate system, main important point in both these cases is that this is always with respect to a frame of reference, which is an absolute frame of reference. It may be the origin of the base of the robot, or it may be some other point within the work volume of the robot, or even outside the work volume of the robot. But these two coordinates or these two positionings are always absolute positioning with respect to some absolute frame of reference. However, the third type of coordinate system is called as tool coordinate system or tool coordinate motion, where the origin is always located at the wrist end of the robot. As you can understand, in this case your wrist is always moving in case of the robot, so obviously this position is a relative position. This position will always keep on moving. The XY plane is oriented parallel to the faceplate of the tool, whereas the Z axis is always along the axis of the tool. Now this particular type of coordinate system is typically preferred in case of applications where the end effector is in the form of tool. For example, you may have a tap, or you may have a drill, or you may have a welding torch, or you may have a spray painting gun. as the end effector, and in that case this particular type of method is more useful, because now we are talking about only the position, only the operation of that particular tool with respect to the wrist position. So for defining the operation of this particular tool, the tool coordinate motion is typically used. As mentioned earlier, for the programming method, in this case as well, we may use either of these three methods for defining the position in space, or we may use combination of these three or any two of them in the particular application, depending upon the requirement for the robot during the programming. So at this point we'll stop on this particular topic. As mentioned, our next part is going to be textual programming languages for the robot, which will be uploading very soon. So as I mentioned earlier, please subscribe to my channel so that you will get automatic updates on the further videos on the further topics, and also please give the suggestions and feedback in the comments to this presentation. Thank you all. Thank you for your patience listening.